Okay, question number 3. A primary clarifier has a length of 12 feet and a width of 8 feet with a depth of 15 feet. Calculate the volume in cubic feet. So we're talking about a 3-dimensional object. This could be a tank, a reservoir. There's several different terms that we use in this industry. But essentially this is a rectangular tank. It's got a length, it's got a width, it's got a height or depth. The ABC math formula sheet is going to have it in alphabetical order. Volume of a rectangular tank equals length times width times height. So I'm going to rewrite that formula using those parameters. We have a length of 12 feet, width of 8 feet, and a depth of 15 feet. So I want volume, and it's going to be in cubic feet. I'm looking for cubic feet, which is feet cubed. Okay? Equals the length. And the length is 12 feet. And again, I write that unit of measure in feet over 1. The width is 8 feet over 1. And the height, in this case, is 15 feet over 1. So let's look at my units of measure. Make sure, I want to feel assured that ultimately I'm going to get cubic feet. And I do that by looking at the units of measure first. I've got 1, 2, 3. All 3 of them are above the dividing line. So when I multiply them together, I'm going to get cubic feet. Okay. What'd you get?
1440
Feet. Cubic feet.
1440 cubic feet?
Mm-hmm.
Perfect. 1440 cubic feet. Now, this isn't in the guide that I gave you, in the study guide, but every operator, there's several different things every operator should know working in this industry. And one of them is that there are 7.48 gallons for every cubic foot of volume. That's a constant. It's in your ABC math formula sheet. There are 7.48 gallons for every cubic foot of water. So because I just solved this for cubic feet, I can very simply take that number, multiply it by 7.48, and I'm going to get the volume in gallons. Now I can write it just like this. Volume in gallons equals volume, which is 1440 cubic feet over 1. That's the answer we got. And I'm going to multiply that by 7.48 gallons per cubic foot. So now I can cross cancel. I've got cubic foot over 1, and over here I have gallons over cubic foot. So over here, cubic foot is above the division line. Over here, it's below the division line. That means when I'm multiplying straight across, I can cross cancel those out because the unit of measure I'm looking for is gallons. So I'm going to cross cancel this and this. I'm left with gallons, and that is the unit of measure I'm looking for. Who did the calculation?
Okay.
$1,440 times 7.48.
$10,771.
Do you agree with that? Yes? Perfect. 10,771 gallons. So I just added a little twist to it, just so you could see. This is something every operator should know. Should be memorized, should be second nature. And there's several of these constants that we should know. And we're gonna review those. We're gonna learn those as we move along through this program. Okay. So this problem is calculate the volume in cubic feet of an 18-foot deep clarifier with a diameter of 12 feet. So this is a cylinder starts with a circle, right? It's circular, a cylinder. And it looks like this. This could be a tank, a basin. There's several different terms we use for something like this, something that holds chemical or water, things like that. So in this case, we've got a clarifier. And it doesn't matter that it's a clarifier. You know, the questions that you get on your exams, it's gonna say a clarifier, a tank, a reservoir, things like that. And it doesn't really matter what it is. What matters here is that you're looking for keywords like volume. You're looking for volume. You're looking for, well, it's a diameter. It's got a diameter of 12 feet. So when you see diameter, you know, and then you see deep, you know that you're looking for a cylinder. That's the formula that you want to use. And the formula that's in the ABC math formula sheet is volume of a cylinder equals 0.785 times the diameter squared times the height. Now, I'll write it out a different way because I like to go step by step. So I'm gonna do volume, and they're asking for the volume in cubic feet, equals 0.785. Now I need the diameter. The diameter is 12 feet. So I'm gonna write diameter 12 feet over 1. I'm gonna do it again because it wants 2 of them, right? So diameter 12 feet over 1. Now this basin, this clarifier, is 18 feet in depth. So here it says height. I'll do height equals, or is, 18 feet over 1. So let's check it real quick. The unit of measure I'm looking for is foot cubed. This is in 3 dimensions. Foot cubed. So I have foot here. It's above the dividing line, multiplied by foot above the dividing line, by foot above the dividing line again. 1, 2, 3, and I get cubic feet. So now all I have to do is multiply this out, 0.785 times 12 times 12 times 18. Did I?
I get 2,034.
Equals 2,034 cubic feet. I believe you, but let's take a look at it real quick. 0.785 times 12 times 12 times 18, 2,034.72. Yeah, good. And you just went ahead and rounded, and that's fine. You're gonna have multiple choices on all these exams, and what you wanna do is find the most correct answer. This is very important to understand, because you might not get 2,034. You might get the closest, most correct answer might be 2,000. Okay, with that said, I'm gonna remind you that every operator should know certain things, certain constants. Now, one of those is there's 7.48 gallons per cubic foot. What that means, if I have one cube that's 1 foot in length by 1 foot in width by 1 foot in height, if it's a perfect 1 foot by 1 foot by 1 foot cube, then it would hold exactly 7.48 gallons. So if I want to convert this to gallons, I would go ahead and write it like this. Volume in gallons equals volume, which is 2,034 cubic feet over 1, and I'll multiply it by my constant 7.48 gallons per cubic foot. I've written it here, but it's a constant that's going to be in your ABC math formula sheet too. So 7.48 gallons per cubic foot. Now, this is why I write out these equations the way I do. That's why I start out with foot over 1, foot over 1, foot over 1. Over here, I have 2,034 cubic feet over 1. And over here, there's 7.48 gallons per cubic foot. You'll notice that cubic foot is above the division line here, and it's below the division line here. And so when I multiply them, that means that I can cross cancel. I can take out this cubic foot and this cubic foot, and I'm left with gallons, and that is the unit of measure I'm looking for. So if I take 2,034 and multiply it by 7.48, I get what'd you get?
15,214.32.
0.32
Yeah.
gallons. I'll just go ahead and round it. 15,214 gallons. Excellent. All right. Okay, this question is find the volume of a cone with a diameter of 13 feet and a height of 7 feet, and you want it in cubic feet. Okay, so they're asking for it in cubic feet. So now we know we're dealing with a three-dimensional object, and just like a cylinder, right, we have a cylinder, a cone is also cylindrical. It's just a little bit different. You can pick any point along here, say there, and you could draw a line like this and like that. A cone might be dead center, like this. It might go out to this side. But what we have here is we have a cone. A cone is always going to be 1/3 the volume of a cylinder of the same proportions. What does that mean? Well, what that means is I have a cylinder. In this case, it's 13 feet in diameter, 7 feet in height. Because it's a cone, I need to calculate what 1/3 the volume is of that cylinder. So what that means is I'm going to calculate volume, and they want it in cubic feet, equals, now I'm going to multiply it by 1/3. Because a cone is 1/3 the volume of a cylinder with the same proportions. And these proportions are going to be, and first I got to put in my 0.785, right? So what's the diameter? The diameter is 13 feet. diameter times diameter. And then we have the height of 7 feet. Okay, so let's check our units of measure here. I have foot, foot, foot. All three are above the division line. That means when I multiply them together, foot times foot times foot, I'm gonna get cubic feet, which is the unit of measure that we're trying to solve. So, this is very simple. You just follow the instructions here. They're all laid out for you. And what you do is 1 divided by 3. You want to follow along with me?
Yeah.
1 divided by 3. And then hit multiply. 0.785, just like here. Then multiply 13. And then multiply by 13 again. And then multiply by 7. Now the answer you got was 309 or 309.55, and then there's some other numbers behind it.
Yeah.
The unit of measure is in
Cubic feet.
cubic feet. Okay?
So 310.
And you might round that off to the best answer, which is on that study guide I gave you,
310
310
cubic feet.
cubic feet. Very good, George. Now, there's a unit of measure, a constant that every water wastewater operator should know. We've discussed it before. It is, there are 7.48 gallons of water for every cubic foot. If I have a cube and it's 1 foot by 1 foot by 1 foot, perfect. And if I fill it up with water, I'm gonna get exactly 7.48 gallons. 7.48 gallons per cubic foot. So just for fun, even though it doesn't ask for this, we're gonna write a formula down to say volume in gallons is equal to the volume, which is, we'll call it 310 cubic foot over 1. Multiply that by 7.48 gallons per cubic foot. And that should give me gallons. Just to be sure, I'm gonna cross cancel. So cubic foot here is above the division line. Cubic foot here is below the division line. When you multiply those values straight across, that means you can cross cancel. So this one, I got the wrong color. I need this color. Cubic foot here, I'm left with gallons, which is the unit of measure I'm looking for. Have you calculated that out yet?
310 times
310?
times 7.1.
Yep.
2,318. Is that right?
Yeah, that's right.
2,318.
2,318.8 to be exact.
Okay, so 2,318.8, we can round that up to 2,319 to 3,220, whatever the most correct answer is. And it's not in your choices in the homework I gave you, because I'm taking you an extra step. First, we solved for cubic feet. That was the question we had on our study guide. But just because you're water wastewater operators and you're gonna encounter this in your career more times than you can count, I'm helping you solve for gallons, okay?